Okay, I think we got this rolling. All right, welcome to Unit 6, Lesson 2, Solving Exponential Equations, Part 1. Now, the year that I am recording this is the 22-23 school year. This particular lesson is going to kind of straddle the A-Day, B-Day thing. So for some of you, I'm going to be in class and will be able to present this lesson. For some of you, it's going to be on a day when I'm absent. So, of course, this video can be used by anybody who misses a lesson or just needs a refresher on how to solve exponential equations that do not involve logarithms. But I am recording this with the fact in mind that I know I am not going to be there for at least a few of you on the day that we cover this material. There is a guest with us. Oh, he's going to get up and leave. Okay, great. One of my cats was sitting right next to me, the one who was at the vet the other day and has some issues. So, but I guess he doesn't want to do a math lesson. I don't know. But the rest of us are in it to win it. So without further ado, let's get going. I wanted to start off with a recap of what an exponential equation is. And we kind of addressed this in the last lesson, which some of you I was there for, and the other half of our A-Day, B-Day kind of tandem I was not there for. So with what is an exponential equation? We need to know how to know what we're looking for. We need to know what to look for in the equation if we're going to pick the right strategies for solving it. So an exponential equation is an equation where the variable is in the exponent. Okay, so we spent a lot of this year talking about polynomials. Polynomials, you would have like the variable is the base, and then you might have the exponent being a number. But in an exponential equation, we are dealing with the opposite. So the base would be a number and the variable would be the exponent. So that is the type of equation that we're looking at here. Now, there are two main strategies for solving exponential equations. One of them is writing both sides with the equation with the same base. Okay, and that does require a little bit of intuitiveness about what exponents are or what your powers are. It works pretty well as long as the base in question is going to be a fairly small number. And then the other strategy is using logarithms, because not every exponential equation can be solved using the first strategy. It is a great strategy when it works. It's actually pretty clean. It's pretty easy to follow the steps. The problem is it doesn't work all of the time. So this lesson is going to cover that first strategy. So now we've got ourselves oriented a little bit better as to what an exponential equation is and what options we have for being able to solve those equations. Now, a little bit of vocabulary here. We need to know which part is the base and which is the exponent. So when we're talking about exponentials, we have like b to the x power, okay? This is the base. Okay, so if you had, say, x to the third power, the x would be the base. Okay, that is not exponential, but the vocab doesn't change because math is, consistent like that. Get rid of that. Okay, and then this here is the exponent. The exponent is what's called a superscript, super meaning above, script meaning writing. So your exponents are a writing that is above the line of the actual problem, or like the main size that we would write our letters and numbers at. Okay, so we have the base and we have the exponents. So when we talk about writing each side of the equation with the same base or with like bases, what we're referring to is this number right here, okay? And we want to get those numbers to match. Okay, so here's our intro problem, and I think this is fairly intuitive, but I do want you to take a moment and think about it. If you have 3 to the x equals 3 to the 5th, what does x equal? I'm going to pause and let you think about that. Okay, 3 to the x equals 3 to the 5th. What does x equal? Hopefully you answered this, you answered that x had to be equal to 5. And you could reason that out by thinking, well, if x was anything else, so if you said x was 4, okay, then you'd be looking at 3 to the 4th equals 3 to the 5th, which we know is not true. Anything other than 5 would give us a false statement. You could also think of it this way. Well, like if the 3's match, then the exponents would have to match as well because of what we know an equal sign means. Okay, so that brings us to our key idea. Okay, our key idea is this. If b to the x is equal to b to the y, okay, and I want you to notice something. I'm going to pause for a second there. These numbers have to match. Okay, right there. Those two numbers have to match. Then x must be equal to y. So kind of think about this for a second. If you have, again, 3 to the x equals 3 to the 5th, then what you've got there is the b values or the bases are matching. Therefore, the exponents would have to be equal. So x would have to be equal to, over here, it's a y, but in this case, it's a 5. So x is equal to 5. If you had something like 3 to the x equals 2 to the 6th, now you can't do anything with that, okay? Like x does not equal 6. In fact, we could be pretty sure that, like, of all the numbers out there that it could be, it's not 6, because 3 to the 6th power cannot be equal to 2 to the 6th power, okay? One is 3 factored in 6 times, the other is 2 factored in 6 times. Okay, so in that case, you can't conclude that x is equal to 6. He came back. He's hungry for math. He's a very good boy. He is. All right. Okay. And I don't have the heart because I know he doesn't feel good, so I don't have the heart to kick him off my lap here. His name is Vasya, if anybody is just curious, because I know some of you are already curious. Okay, now this is true so long as b does not equal 1. Okay, so we do have a little bit of an exception there. I don't know if that's the kind of thing that might pop up on like your EOC or not, but because we ask interesting questions. So what happens if b does equal 1? Like, why doesn't this work? So if b does equal 1. Suppose you have 1 to the x is equal to 1 to the 5th. Well, could x equal 5? Sure. But notice this. If you had 1 to the 4th, that would also be equal to 1 to the 5th, okay? Because that's just 1 times 1, 1 times and 4 times versus 5 times. But anything times 1 is itself, and you're just multiplying it in. 1 is what's known as the multiplicative identity. Okay, so it does behave differently from other things, okay, from other numbers. And we could probably apply the same thing to 0 here. The thing that I wrote said that b had to be greater than 0, but not equal to 1. And I kind of left that part out because negative numbers, you could reason your way around it, but the same thing would happen if you had 0, like 0 to the 4th would be equal to 0 to the 5th, okay? And 0 is the additive identity. So zeros and ones, even though they're my favorite numbers, okay, do some weird things, okay? And so we don't want to, apply things that would work for 0 and 1, don't necessarily work for everything. So we want to be careful about zeros and ones, and we want to focus on the key idea. Just know that there are some limitations to that key idea. Okay, so we're going to work through, I think, 4 examples is pretty much the body of the lesson here. And it's just to give you some steps that you can go back to. You should be filling in your notes or writing this down because the idea is that when you go to look at your homework or when you go to look at your classwork, that you are going to be filling in or looking back at your notes. Okay, you're going to be looking back at your notes and at the steps in your notes. So suppose we have this exponential equation right here, 2 to the x equals 8. The reason I know it is an exponential equation is because I have the variable in the exponent. And so my first step is to write both sides as a power of the same base. Now, to do this, you might need to grab a calculator. If the numbers are fairly small and you've been faithfully doing the work that we've been doing all year, then you start to develop a pretty good sense of, like, you know that 8 is the power of 2. In fact, you might know that it is 2 to the third power, just because you've seen it so many times. If you don't retain that as well, or you just have been neglecting all your work, so you're like, what do you mean 2 to the third? That was 6. Oh, 6. 2 to the third is 8. Then what you would do is you would grab your calculator and you just start playing with it. Now, I have a couple tips here. Try writing the larger as a power of the smaller first. So you've got these two numbers here. You got a 2 and you have the 8. Okay, that's not working. Okay, a 2 and an 8. Take the 8 and see if you can write it as a power of 2. So you would just do like, okay, 2 to the first is 2, 2 squared is 4, 2 to the third is 8. We have a winner, ding, 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 ding. And so the smaller number we would keep the same, 2 to the x, and then would replace 8 with 2 to the third. Please work top to bottom, top to bottom, top to bottom, top to bottom, not left and right. The reason for that is that we keep like pieces of our equation in the same location. So 2 to the x is going to line up with 2 to the x. Equals is going to line up with equals, and 8 lines up with 2 to the third. Why? Because 8 is equal to 2 to the third, okay? So we're making that substitution and we can see where it is. If you're writing it over here, then your equal signs are far away from each other. Your 8 and your 2 to the third are far away from each other, and it just makes everything so much harder to follow, okay? Now, if this first thing here does not work, and we will take a look at an example of that, then try making both bases smaller, okay? So it might mean that both of the numbers can be written as a power of something even smaller. So if you had, say, a 4 and an 8, you cannot write 8 as a power of 4, but you can take a 4 and an 8 and write them both as a power of 2. Now, if that doesn't work, then this strategy doesn't work, and then you have to kick over to the other strategy, which is to use logarithms. Not going to happen in today's lesson, all right? Once you have done that, you can set the exponents equal. Okay. So in this case, we have x and 3. So we're going to write x is equal to 3. And then step 3, solve the resulting equation, which in this case does not involve any steps, okay? Because once we had the exponents, one of the exponents was just an x, and so there was nothing to do. Now, if you haven't written down those steps, pause the video right now. Make sure you write down those steps. Do not photomath this. Do not assume that the internet has which is ironic if you're watching this on the internet, but that the internet out there, like especially some kind of AI thing, it has some better way of doing this, okay? There are other ways to do it, but I really do endeavor to find the most straightforward way for you guys to think through and work through and process these problems in a way that you're going to understand. Not just get a correct answer, but a way that you will understand. All right, let's look at a couple more examples. So we have here 5 to the 5x equals 125 to the x plus 1. And again, notice that this is exponential because of the location of the variable. The variable is in the exponent. Step 1, write each side as a power of the same base. Now, the first tip I had was try to take the larger of the two numbers and write that as a power of the smaller number. Okay, that is often going to work in these problems. So you can grab your calculator and do this. I don't necessarily expect you to just know all of these off the top of your head, especially if they're kind of weird numbers or big numbers. So you might do 5 to the first power, 5 squared, 5 to the third. Oh, we have a winner, okay? So I'm going to copy down 5 to the 5x, and then right here, we are going to have 5 to the third. Again, work top to bottom, top to bottom, top to bottom. So this side is coming down, the equals comes down. 125, we are going to use the equivalent of 125, which is 5 to the third, and they're written right above each other. Now, at this point, I'm going to pause and use a story analogy, okay? So I want you to picture like the exponent right here. We have this exponent of x plus 2, okay? And I want you to picture the super cool kids that are snobby, not the super cool kids who are nice, the super cool kids who are snobby, and they have their club. Okay, now in this case, we're going to talk about the super cool exponent club. Super cool exponent club. Okay, x plus 2. They're exclusive. Exclusive means that they're picky about who they let into their club. They don't really want new members. They are setting themselves. Being exclusive is the opposite of being inclusive. Okay, they are not welcoming. They are the people in the cafeteria. When you're a new student, you come and sit down your lunch tray, and they say, "We don't want you to sit here. We're cool." Okay, now that's what our exponent is going to do here. Okay, they're not nice. They're not nice people. Don't be like them. Okay, they're not nice people. So what they're going to do is they are going to put up their super cool exponent walls. Okay, super cool exponent walls. No, 3, we are not welcoming you to our exponent party. Not gonna happen. We don't want you as a part of our party. Now, I did that illustration one year, and a girl raised her hand, and she goes, "Who hurt you, Miss Taylor?" Which I thought was hilarious. I do think the experience of being shut out is probably pretty universal. So probably everybody watching this video has experienced that somewhere, somehow, where they have been like on the excluded side. That's not like the point of the illustration is that we need those parentheses there. So we're creating our super cool exponent club in order to create like a visual or an analogy that's going to remind us that, oh, that x plus 2 was grouped together in the exponent, and that grouping still needs to apply. So the entirety of the 125 had been raised to the x plus 2 power. And so we're going to take the 5 to the third, and that also needs to be raised to that power, okay? So there's step 1. Step 2, set the exponents equal. Now, try to avoid saying that the 5s cancel out. Like, yeah, but like a lot of times when students say cancel out, what they're picturing in their head is division, and there's definitely no division happening there. So I want to avoid using that language for this. We're going to go ahead and set our exponents equal. So we have 5x is equal to 3 times x plus 2. And now we have a linear equation instead of an exponential equation. Step 3, solve the resulting equation. So I'm going to go ahead and distribute. So we'll get 3x plus 6. And then I'll go and subtract the 3x from both sides. So 2x is equal to 6. Divide both sides by 2. And x is equal to 3. And we have an answer. Okay, couple things I want to point out. Notice top to bottom, top to bottom, top to bottom. Every line follows from the line above it. If you can't tell, or if you're from another school or something, you're watching this video, I don't know, it's just out on the internet, anyone can watch it. So, but you might gather that this has been an issue this year, is top to bottom. Okay, if you say, where did the 6 come from, you should be able to look right above it and see the 3 times 2. Oh, there's where the 6 came from. When you are operating on both sides, what we mean by that is both sides of the equal sign. I keep seeing students that are like, say, subtracting, and they'll say subtract from both sides, but what they've done is they've subtracted from the same side twice. So they have 2 subtractions there, but they're both on the same side of the equal sign. So make sure that if you are subtracting or if you are dividing on both sides, that you do actually have that operation on both sides of the equal sign. All right, next problem. we have 9 to the 2x minus 1 equals 3 to the 6x. Now, this one was written so that we actually are like the bigger numbers on the left, something that I was doing inadvertently, and looking at the homework, I've kind of done it on the homework as well. And it's not intentional, is I usually put the smaller number on the left and the larger number on the right. It's just how I write the problems. And so I wanted to make sure that I got at least one problem in here where the larger number was on the left, okay, because it doesn't change our strategy at all. So step number 1 is write each side as a power of the same base. And our first strategy here is going to take the larger number and write it as a power of the smaller number. So we're going to take 9 and write it as a power of 3. So you might grab your calculator and do 3 to the first, 3 to the second. Oh, we have our winner. So right here, we're going to replace 9 with 3 squared. These guys are super cool, so cool that they don't want any new members in their super cool exponent club. Okay? They don't want the 2 joining their club. So they put up their exponent walls, their club walls, and say, no, we are not taking new members. Sorry, 2. Not joining our party. Okay, and this is to remind us that we do need to distribute. Okay, so whatever works. If it helps you remember it, then the story has served its purpose. So step 2, once you have the same number here, you're going to set your exponents equal. So we will have 2 times 2x minus 1 is equal to 6x. And you are welcome to distribute as you are copying it down. A lot of students would do that. So they'll just kind of do 4x minus 2, and they'll write this down here as 4x minus 2. And that's totally okay to do. Okay. So in terms of like, well, how much work do I have to show? Can I skip that? Yeah, you can skip that. All right. And step 3, solve the resulting equations. So we'll go ahead and distribute 4x minus 2. And here you can do this multiple ways. I'm going to go ahead and subtract 4x from both sides. I might show you the other way just because somebody's going to try to do it and then they're going to get confused. So this leaves us with negative 2 is equal to positive 2x, and then we'll divide both sides by 2, and we run out of space. We get negative 1 is equal to x. And you can leave it like that. You can also use the symmetric property and write x equals negative 1. That's totally fine to do, okay? Now, just because, like I said, somebody's going to do it, okay? So I'm going to clear out a little bit of space out here and just work this a slightly different way. So right here, we have like the 4x minus 2 equals 6x. Somebody is going to do this. They're going to subtract 6x from both sides, okay? Which is fine to do. It's just, I think sometimes people go on autopilot, and they're like, they always take whatever's on the right-hand side, and they're like, I'll add or subtract that and get it over to the left, and you can do that. It's just kind of an autopilot kind of move. 4x minus 6x is negative 2x. And then you have the minus 2, and then we bring down the equal sign. And remember what I said about working top to bottom, always top to bottom. So 4x minus 6x is negative 2x. The minus sign comes down, the 2 comes down. You might have also noticed that minus sign had to come down right here. Okay. And then they don't know what to do. So then the equal sign like vanishes. Equal signs should not vanish. They should not vanish and like reappear in the body of your problem. 6x minus 6x is 0. Which is a thing. And then we would add 2 to both sides to get negative 2x equals 2. And then divide both sides by negative 2 to get x is equal to negative 1, which is, of course, the same answer. And it should be the same answer because it is the same problem. But a lot of times I will see that happen where students subtract in a way that gives them 0 on one side. And then they often end up moving the equal sign, which sometimes they can get away with depending on whether the numbers are positive or negative, but it often causes a mistake and it is erroneous. You don't just, move stuff. So just be careful about that. All right. One last example. Okay, so fairly short lesson. So this one is 4 to the 2n minus 1 equals 32. So if you think back several slides, it said try to write the larger number as a power of the smaller one. And so in this case, you might grab that 32 and you're like, okay, I'm going to write 32 as a power of 4. And so you write like, okay, 4 to the first power is 4. 4 squared is 16. You can grab your calculator and do this. 4 to the third power is 64. And we're like, uh-oh. Uh-oh. That is supposed to say uh-oh. Meaning we jumped over the 32. So there is no 32. Like we jumped from 16 all the way to 64. There is no 32 here. And so what this means is that 32 cannot be written as a power of 4. Now you might be thinking, but I'm pretty sure that 4 times 8 is 32. Yes, 32 is a multiple of 4. It is not a power of 4. So yes, you can multiply 4 by something and get 32, but you cannot raise 4 to a power and get 32. And vocabulary, vocabulary, vocabulary. Okay. Now, if this happens, the next thing you're going to try to do is you are going to try to take both the 4 and the 32 and write them as powers of the same base, namely something smaller. Okay, so if you think, okay, well, what could I write 4 as a power of? Most of you would say, well, that would be 2. Okay, and so you grab the 2 and you're like, all right, 2 to the first power is 2. 2 squared is 4. All right, we have a winner right there. So I'm going to take out the 4. I'm going to put in 2 squared. Super cool exponent club coming on the scene, not letting the new 2 in. Okay, and now we have to keep going. So 2 to the third power is 8. And again, use a calculator for this if you need to. 2 to the fourth power is 16. 2 to the fifth power is 32. And there's our other number. Okay, top to bottom, top to bottom, top to bottom. 4 is replaced by 2 squared. 2n minus 1 comes down. The equals, now I know it got like shifted over because I had to make that longer because I can't write as small as I can type, but the equals comes down and the 32 comes down. If you write it over here, everything is too far away on your page from the previous thing that you were doing. Okay, be patient. Don't try to take shortcuts. Shortcuts often leave you astray. Okay, so grab your calculator and just start plugging in the numbers. I promise it doesn't take a long time. Step 2, set the exponents equal. So we're going to have 2 times 2n minus 1. Again, feel free to distribute that as you're writing it down. And now we'll go ahead and distribute. So 4n minus 2 equals 5. And step 3, solve the resulting equation, which I guess I already kind of started doing. Okay, so we add 2 to both sides. So 4n equals 7. And then divide by 4. And then half of students panic because they're like, what? It's a fraction. Yeah, kind of is. Fractions are okay. All right. Now, remember that you can also use Desmos to check this. So just like with anything else, you can graph the left side, graph the right side, see where they intersect. You're going to take the x coordinate of the intersection. If that number is 7/4, then you know that you have done the problem correctly. Okay. There we go. If you are using an app to help you with your homework, remember that you have to solve it this way. Okay. So don't copy down stuff you don't know. And often they will introduce strange notations and extra steps. Your AI computer-based problem solving stuff, they often do a lot more steps than is necessary. Okay, so just copy the example problems. All right, trust the plan. It's a good plan. Okay, in-class practice. Now, this is to be uploaded to Focus. If we are doing this, if you're in class, if it's one of the days I'm there, then we'll obviously pause here. But if you're doing this on a day when I am absent, then you're going to take a photo of your work and upload it to Focus. Remember that I am not going to be there like at the end of the day to go get your work. Okay, so if you throw it in the turn-in bin, it is just going to sit in the turn-in bin for like a week. Okay, at least the year that I'm recording this, because I am out on bereavement leave and I'm not coming back until after the break. So take a photo, upload it to Focus. If you need to bring the assignment home to get a photo of it to upload it to Focus because of Wi-Fi data, whatever, go ahead and do that. That's fine, okay? But make sure you get that uploaded to Focus. So we have the following problems. 9 to the 4x plus 2 equals 27. And 81 to the a plus 2 equals 3 to the 3a plus 1. So you're going to pause the video, take some time, take a nice sheet of paper, work these problems out, okay? Work them out on your sheet of paper. And then unpause the video when you have had a chance to do that. It'll probably take you 5 to 10 minutes, okay? Depending on how much of the lesson sticks the first time. Okay, now here are your answers. So before you take that picture and upload it to Focus, and if you already have, we're just gonna fix it now, okay? The answers should be x equals -1/8 and a equals 7. Sorry, I didn't bother making those lowercase. Sorry. All right, so if you got them wrong, please take them out. Now, do not erase all your work, okay? So if you got them wrong, what I would like you to do is go back into your work and see if you can find your mistake, okay? And hopefully I didn't make a mistake, but yeah. So go back into your work, see if you can find your mistake, fix the mistake, run it by a neighbor, okay? This might be a good time to go open up that app, okay? Once you've worked the problem, you're like, oh man, I got it wrong. Now use the app to see if the app can help you diagnose where your mistake is. That's a good use of using an app, okay? As opposed to, I will just copy down a bunch of stuff, which is bad use and does not pay off. All right, so once you've cleared that, go ahead, get that uploaded to Focus. If you cannot upload it from school, okay, and you need to wait till you get home, I want you to right now put a reminder in your phone. Put a reminder in your phone for later today so that you don't forget that there is a piece of work in your backpack that needs to get uploaded to Focus. Okay, so pause the video and give yourself a reminder or upload it. And homework to be turned in next class. Okay, so hang on to this. Do not upload this, because especially for those of you that I am not in class to present this lesson, I am expecting for you to have questions. Okay, I'm expecting to get some feedback from you. Okay, you are not expected to be able to self-teach everything. So we're going to do this. You're going to work on some classwork. You're going to try the homework, but give yourself some time to percolate with the ideas and ask questions when we come back and I see you in class again. Okay, so that should be a wrap on that. I will be active online over the break, but not all the time, because as you know, I have some family stuff going on. So just let me know if you have questions. I will get back to you as soon as I can. And remember, for those of you that are watching this prior to spring break, that you do have an at-home test that needs to be finished. Just gonna throw that out there. If anybody else is watching this, you just ignore that, okay? All right, so let me know if you have any questions.